Welcome to the latest edition of the Frac Sand webinar series. I'm pleased to welcome Optimus Solutions as our presenter. Just a little background. I was chatting with Tom Zhang probably a couple of months ago now, on unrelated topics, and we got chatting about some of the services they provide in evaluating frac sand assets for acquisition or disposition. And I invited him to provide this webinar because I thought that'd be of great interest to the industry, especially with all the changes going on, some of the assets that are now becoming available due to shifts in locations of frac sand demand and production. So I'm pleased to have Optimus Solutions there. Just a quick background, if you're not familiar with them, they have been at some of our events recently as sponsors. But they're an engineering consulting firm, and really they're focused on, I love their quote, the science behind the process. And a large reason for that is Dr. Tom Zhang's their senior engineer, really their lead engineer from their start in 2015. He has a PhD and a BS in mechanical engineering from Mizzou, University of Missouri. And he, like Optimus, he really focuses on rotary equipment and industrial process. And I'll let Tom give a little bit more background on Optimus and perhaps on himself as we jump into this topic that I think is of great interest. We certainly, based on the number of registrations, it looks like it's of great interest. This is the largest number of registrations we've had for a webinar. And I think I'm looking forward to hearing more about it. Hopefully you'll get a lot out of it as well. Tom, I'll hand it off to you and we'll take it from there.
Hey, I appreciate it, Pete, and I appreciate you guys attending the webinar, and let's start. So the main goal today is to talk about asset acquisition and disposition. Just to get things rolling, who we are, who Optimus is. We're an engineering consulting company. We concentrate in industrial processes. So we're in all sorts of industries: food, cement, frac sand, lime recovery, pretty much anything that requires something to be dried, something to be chemically altered with heat. We're probably in that industry. I think Pete mentioned we're into rotary equipment. That's where our deep experience comes in. We deal with a lot of different rotary equipment, rotary kilns, rotary dryers, rotary granulators, ball mills, anything that turns, we probably can deal with it. We got some sister companies that deal with the field service side, some of the OEMs that we work with. So a lot of that information we know quite a bit of. Extensive database. I've done a lot of different units now, and I can start getting their efficiency. The science behind the process is in grounded engineering principles. That's a way we could reduce the risk, because the more we know on the front side, the less guesswork you have to do on the back side. And ROI is one of the major focuses, because ultimately if you're not going to get your return on investment, who cares, right? And lastly, we've been in the frac sand industry when it was starting to go up, and we can kind of see all the ups and downs, the bumps, the successes, and that ultimately leads to why we're having this discussion today, especially with the COVID-19 out there and a lot of ups and downs in the industry. There's a lot of uncertainty in the market. And we got lots of calls from different customers, or we've been in discussions with a lot of them. Plants are idling, and this is where if you're a buyer or a seller, this is where doing a little bit of upfront homework starts to become important. So the current problem and certain in the market, and let's dive into a few questions. So most people that buy a piece of equipment or buy a plant or buy something to move from one plant to another plant, typically these are the two most common questions that I get asked. Is it in good shape? Can I mechanically use it? And can we move it? How much does it cost to move it? You can get a dryer in Pittsburgh and you want to move it to Texas. Well, how much does it cost to ship? The part that's interesting is, what are you not asking? Because the what are you not asking is the difference between a great investment and a sunk cost investment. So I got an interesting story on a customer we just did, I think a few months ago. So they had a new plant that they wanted to build. And what happened was, we did an inspection years ago, and they had that inspection, so they called us. So they had a piece of rotary equipment that they made sure was in great mechanical shape. They made sure that they could move it logistically and it'd be financially viable. But the process was more or less an afterthought, because they thought, okay, if I take this and put material in it and it'll work, it's more like, okay, if we put it in and we put the heat on it, it'll be fine. Well, what we found out was, this was a different rotary technology. This was a rotary kiln versus a rotary dryer. So the distinction is, on a kiln is very high temperature, and you take it from one chemical to another chemical. Whereas on a dryer, all you're trying to do is remove moisture. And that subtle detail in just choosing the technology caused a lot of problems, because they had a predicted production that it would be able to do. And because it was a kiln, there were other obstacles. They had refractory. In your dryers, you typically have flights, so there were some significant modifications I recommended. The size was too small. The heat transfer was not right. And it was maybe half of the production that they promised to the investors, with significant modifications. They even told me that if we would have talked to them months ago, they probably wouldn't even invest in that technology or that piece of equipment, or B, not try to keep the refractory in it. And right now, they're still in the middle of trying to decide if they want to keep it or not. And we're in discussions with other groups that could use a kiln or not, because the process they use, it just was not viable. They would have got ash coming out of the kiln, because it would have been so hot, it would have destroyed all of that material. So that's kind of some background on a story that we have. So what I recommend is, before you buy a piece of equipment, or before you set in motion how to move it and is it in good mechanical shape, it's worth doing a little bit of mental homework up front. And these are all very common sense things to do. It's just typically when you get into the deal, sometimes you'll miss these details. Is the expected production rate selling at a profitable market price? Frac sand right now may or may not be profitable in terms of selling that piece of equipment or getting into that market for that piece of equipment. Maybe it's worth shifting to a different market. So one of the questions will be, how are you predicting or calculating the theoretical production rate? If it's an existing plant, you can get logs. If it's a piece of equipment that's sitting in a boneyard, well, it's worth calculating how much can go through versus it should be about this much. And if you can figure out how much it can go through, now you can start building your return on investment case for your business. The other side of it is, how much should you sell price-wise, or how efficient can you run that financially makes sense? That's where the cost comes in. That's where the what is your major costs on site. That's typically for these rotary is a fuel, and I like to link it to a fuel efficiency. Typically for dryers, you're talking MMBTU per ton production. That's a very common one. Or what I like, which is MMBTU per pound of water evaporated. It's a dryer. You're trying to get rid of moisture. How efficient you get rid of moisture is another benchmark, but that's not a real common one. Another salient point here is, even if you get an equipment for free, does not mean it's necessarily a good deal, because running equipment has maintenance costs to it. If you got a unit that burns twice as much fuel and you don't know about it, you could be spending quite a bit more where you're keeping your prices up and not making a profit. Ultimately, the end goal is, can we make money off of it, or is this not a viable investment? From an acquisition standpoint, the goal is, if we buy this piece of equipment, is that a low enough price, and is that a good enough mechanical shape and good enough production rate set that it fits the financial model? If it doesn't, not worth going down that route. Disposition is where I think we can really help on some of the materials on the market. For example, if you're trying to sell frac sand to a market that's not frac sand, is it viable? I know there's some exciting markets out there now that people are trying to get into. This is where we can help, because sometimes just the material itself, knowing if it's a sand or an organic or something that has a very sensitive temperature range, this is where we can help, and our deep understanding of the equipment can help in terms of better guidelines and a better decision point. The overall approach we have is, it's a lot of conference calls. So I like to make sure that before we even start, the client and us have a good understanding of what success is, what the problem is, and what are we trying to solve. So if you have a problem, which is, I want to see if this kiln is the right technology for this drying, then we can go, okay, here's the steps you need to take. You need to take a look at the equipment itself. We can do a theoretical heat mass balance or process evaluation to see if that makes sense. This is where then we agree on, okay, if you're using a kiln for drying, then are these metrics good enough? Is the temperature good enough? Is the airflow good enough? Is the production rate good enough? What, by the end of the calculation or the service or whatever it is this metric what we agreed upon? And this is where the science behind the process comes in. This is where the metrics come in. If it meets it, then it meets it. If it doesn't meet it, then it doesn't meet it. This is where data-driven decision-making comes in. And typically, if we do it in this way, the likelihood of success is very high. And that we keep the data in front of us and not let our emotions get the best of us. Because when you don't get the best news, it's typically more or less, well, what if you do this, and then you squint your eyes a little bit and maybe it'll work. We don't like maybe. We like to have data. If the data's good, great. If the data's not good, then what do we do to either stop the investment or move in a different direction, or we can keep going. So this is also where some tips and tricks. A lot of this is pretty common sense, but it's always good to just go through it again. Do's and don'ts. Do look at logistics and the installation costs. This is a no-brainer. If you're going to move something that costs so much to move, it's not worth moving it. It's worth, if you're buying from someone, or even if you're selling to someone, know the performance log. Know how much production you're making, or how much that unit production's making. How do you know? You know, how most people sell materials. What's the theoretical production range? Units tend to be bought, oversized, or what auxiliary equipment needs to be bought or upgraded. Burners, baghouses, air handling systems. So your best case, your likely case, your worst case. Map out the process model and model the component reliability. How many down days have you had at this plant? How many up days? What's the common route? Evaluate the risks. Do a failure mode effect analysis. Detailed ROI with measurable milestones. Again, it goes back to what are the metrics. Don't just buy, or don't just look only at the purchase price. Free can still be a bad deal. If you have to deal with a lot of fixes on the backside, it's probably not worth it. It depends on the financial model. If you don't have a qualified inspector take a look at a piece of equipment, if you're afraid to spend some money to do some upfront homework, that will save millions on the backside if you do it right. And if you already did spend $1 million and it's not good, then don't chase us on costs, right? This is where emotion comes in, and if you're attached to an idea or a vision or a dream and you're emotionally invested, it makes it that much tougher. That's why one of our core ideals or models for us is to really focus on the science behind the process, or the core fundamental engineering, so that it's data driven, it's fact driven, it's mainly the numbers with the common sense and experience that we have. A few things that makes us unique, just on dryer processes, we got an OEM that we work with and a field service that we're all sister companies with. 500 plus dryer processes. Chicken manure, I mean, I've actually ran into chicken manure more often than you think. Slag, trona ore, soda ash. Anytime we have a market problem or an economic problem where the economy tanks, we typically just shift to a different market, because you can't have all the markets go bad, because people need core fundamental materials. So typically somebody's running and we can actually do more work in that area. So we deal with a lot of different markets. We deal with the cyclical aspects of those markets. Another unique thing is we deal with the OEMs, and this is more or less unique to frac sand. Louisville Dryer, Tarmac, FECO, IAC. We know the ins and outs of all the pieces of equipment. Louisville Dryer tends to be pretty conservative on their designs. They're pretty robust in terms of engineering design. They tend to have some cost considerations you have to take into account. Tarmac and IAC tends to have this V-slanted roller based design that, and Tarmac's trending driven, IAC is chain driven. FECO tends to be a little bit aggressive on their engineering design, so they're a little bit lower cost. They have a great marketing team that you can see them if you type in Rotor Dryer. So all the details we deal with all the time. So if you have a specific question, don't be afraid to ask. And finally, what is the question you are not asking? This is typically the stuff that makes or breaks your process and your financials. So when you guys think about this later, what is the question you are not asking? Thank you.
Thank you, Tom. We're going to transition over to the questions and answer session for everyone. Tom has put together a panel of experts to kind of field the various questions. And while the panel gets ready, I want to let people know, if you do have questions, down at the bottom of the screen, there's a Q&A icon. Click on that, you type your question in there, and I'll keep up to date with those, and I'll read through and then pick the questions to send over to the panel. So let's jump into the questions. Well, actually, I was going to start off with a question, but I'll let Tom first introduce his panel, and then I'll start throwing questions out.
Hey guys, this is Tom Zhang. I'm the senior engineer for Optimus Solutions. A lot of the questions that I'll be trying to answer will be from a risk assessment standpoint, from a technical point of view. I have three other gentlemen with me. Mike Atwell from Industrial Kiln and Dryer. He'll be focused on field service, retrofits, mechanical inspection type of a viewpoint. Randall Young, principal consultant for Competitive Advantage. Similar risk assessment, but more from a business operations point of view. And Trey Mathis, general manager for Louisville Dryer. He will be coming at it from an OEM, new design standpoint. Okay?
Great. Here, I'll start. We have a question that came in. Is there a reliable marketplace for plants that are looking to buy equipment?
Clarification then on that question, if you're talking about a reliable marketplace being a place that is, there's a lot of brokers out there that know of, or will watch the used markets. If you're talking about one place that you can say, hey, my plant's up for sale and here's what it is, I've never come across that before. This is Randall Young with Competitive Advantage. It normally is through different brokers or word of mouth on where the equipment is at. I know that Industrial Kiln has a lot of times that we'll have customers that will call in and say, I've got a piece of equipment either looking for, or I've got a need, or I've got a case where I've got a piece of equipment that I'm trying to sell.
Okay, then as a follow-up on that, how about what of that list that Tom had put up, what markets are actively buying assets, say dryers right now, or are there any that you can share? Someone has a bunch of extra.
I can lead off on that a little bit and then let Trey kind of answer on some because he's very familiar with these frac sand dryers and what they can go into. We're finding that regional aggregate markets, that aggregate as a whole is not totally down, it's regional. We've got conditions where you'll have a certain region that they can't make enough. And then you have other regions that are trying to dry aggregate, be that from sand, gravel, construction, any of those type of things, and they actually don't have enough that they're not running full shifts. Hemp is a big market right now, but that's a different type of dryer. A lot of your specialty chemicals right now are really running full bore. Lime in different regions is running full bore. So there are markets that are down and there's markets that are up, and it's somewhat of it's in commodities, different commodities that are hot, and then some of it is just what regions of the U.S. or of the world are as hot right now. Trey, you want to chime in a little bit about some of the characteristics of the frac sand and what they really can go into?
Well, sure. On the frac sand drying systems, I mean, the basis of design for those systems, that equipment, was to process materials that are non-corrosive, so a neutral pH, neither acidic or caustic, materials that are mildly abrasive, and sand, though it is abrasive, compared to other materials such as iron ore, metallurgical coke, scrap glass. I mean, it's a pretty simple material to handle. Those other applications require some very special abrasion resistant alloys and weld overlays, cast components to be able to handle those services. They were designed to process materials that are non-temperature sensitive. If you hit the sand with 2,600 degrees Fahrenheit, you heat it up to 400 degrees Fahrenheit, you're going to be wasting fuel, but you're not going to hurt the product. A lot of organic materials, a lot of inorganic compounds, even at much lower temperatures, you'll calcine or destroy the material. And these are, it's also designed for processing materials that can come in contact with products of combustion. Certain applications, certain processes and materials, they'll actually chemically change if they come in contact with the materials or the products of combustion, or they'll be contaminated and they can't be used for their intended purpose. So trying to take any of these systems and going beyond those parameters, you're going to be able to operate the equipment at some capacity for some period of time, but you're going to sacrifice product quality, operational reliability, and indeed the life of the equipment.
Great. And kind of related to that, this is Pete Cook. I work with I just provide a lot of introductions, people that have assets that they're trying to dispose of and others that are looking to acquire some used assets. And this might be directed more at Tom, but in most cases I've seen, they have the buying company has an operations manager or an engineer on staff and he's the one that goes out and does that physical due diligence, that goes and kicks the tires a bit and checks out the asset. and obviously that makes sense. You're saving money. You're not hiring a third party. But is there any risk there or downside to using the internal guy? Anyway, I just want to throw that out to Tom.
This is Tom. When you look at a consultant group or an engineering group that's outside coming in, one of the benefits is always fresh eyes. So if that unit, if you're the plant engineer or the plant manager or the maintenance manager, and you see the same thing over and over again, sometimes a different perspective or a fresh perspective is very helpful. Sometimes I always say I'm asking the dumb questions. I go in and ask, why is this running this way? Why should that run that way? Hey, you know what? This component over here doesn't sound right. And that's where it sparks a thought. And then we can go into more details on why. And that's where some of the value comes in on that. And I think Mike has some comments he can make on that.
Yeah, one of the things that we see quite often when you send your own people out to do an inspection of a unit you want to buy, you already got a personal vested interest in it. So your eyes aren't quite as wide open. You try to justify everything that you see that may not be what it really is. Where the gear is worn out, maybe 50%, the guy's like, well, that's okay. Well, is it or isn't it? And what he does is he doesn't note all these items down. And then if you purchase it, then all of a sudden everything starts showing back up again. Then you realize, oh, there was a whole bunch of things wrong with that, and they all add up. And that's where, Tom was talking about earlier, you can get a good deal on a unit, but if you don't keep your mind open and note everything down, you may find yourself in a place where you don't want to be, where you've invested a lot of money, and now you got to invest a whole bunch more that you really shouldn't have had to do if you would have done your due diligence.
Sure.
Peter, one other thing I'll add on to that is that we always have a saying inside our companies that you can't trust the guy that's on the chase. So one of the things that you do is, first of all, you jump straight into the equipment. Okay, we got the equipment, we can go out there and look at it. I'm always going to push back on saying, okay, what is your financial model and what are you trying to achieve with that financial model first? And don't even tell me what the price of the equipment is until you evaluate whether or not that equipment can actually perform, even theoretically or practically, to be able to achieve that financial model. And a lot of times once you start in on a project and you're intimate with that project, your judgment has to be questioned just as it goes through. We do that internally on projects because you just get in love with the chase. We want to win, so you need someone in there that's going to push back on it a little bit to make sure that the right facts are coming up to the surface.
And that's where the perspective comes in on being neutral and being data driven, and knowing why you're helping the team there.
And being data driven, you might just say, sorry, I'm not sharing that information, but early in the presentation, I love what you said. Something along the lines of if you're not going to get the ROI, if you're not getting the return on investment, who cares?
Right.
With that in mind, can you share any examples of ROI on these types of projects?
Well, I actually do have two examples. I'll leave the industries and everything out. One example we did, we had a dryer type of a unit where they wanted to model the flighting inside. And we did this project. It took about 8 weeks. We implemented the design changes. We had a small scale model here that we can do some design work. We started early in the year, we modeled it, they implemented the design changes, and they had, I think, a 10% improvement in production. ROI standpoint, 2-day payback. That's one of the really, really nice ones. Another one more recent is, this is if you have a running unit and you want to be more efficient. We took a look at the burner system on one of our customers, and they had a really high CO amount. So we helped them do some due diligence on it, and they saved a lot of money, cost reduction on fuel. That's about a 3-month payback.
Pete, I can go a little bit more into that too. A lot of times it depends on it's going to be your investors or your company profile on where the tolerance of how much expense over what time. Most of the time I see if it's over 3 years of payback, it should be a no-go. There's too many things that come in. If you're underneath a year, then not lying to yourself on the numbers, that shouldn't even warrant a conversation. That should be a 5-minute conversation, and let's move forward and let's start reaping the benefits. And so anywhere in between there on your payback. The biggest thing I see mistakes made in ROI is that they ignore some cost, either out of ignorance or out of, I just don't want to recognize that that's actually a cost that's going into this project. They're going to be part of this run. And that's exactly why we push so hard on data's data, and data is not emotional. Data is just that, and then you utilize the data to make those type of decisions.
And then what's the I'm revealing my ignorance here, but what's the downside of I think Tom mentioned that most people buy something that's too big for their needs?
Running costs.
Okay.
If you're really buying, it's great if you're going to buy extra capacity because your model shows that you're going to be able to grow into that capacity, and that's future revenues that you don't want to have another investment to make it, in the future. But most of the time, if your unit or your equipment's over capacity to what you're trying to do, it's costing you more each day to run it.
Or cost you more on the repairs, because it's just larger.
Right. And then if you work on a project where someone's expanding a plant, you're upgrading or just want to increase capacity, how much of the due diligence is on the existing plant? Like, is there a site visit on the existing plant before you can even go look at anything that might be added on?
It's a mix.
I'd say absolutely, but yeah, you need to understand all the parameters that you're going to be dealing with before you can start really kind of working the project.
Right, and it depends on the stage. If you need a theoretical, high-level feasibility that, we just need to know if this even makes sense, then that's something pretty quick.
You don't even need the plant for that.
Right. Then let's say you move past that and you really now want to investigate the actual property and the details associated with moving everything. Now we need to go to plan and really study it.
All right. Great. I don't know if anyone else has any questions or not submitted in the Q&A section yet, but I think that wraps it up for me. I was going to ask some other questions related to breaking down and moving assets. But I think it's just that would be too case specific in order to get some numbers. But I get that question quite a bit too when people are looking at used assets and they want to figure out how much it's going to cost to break it down, move it, and put it back up again. But I'm sure that's very very specific to each case to get any even kind of a ballpark number.
That is something that Industrial Kiln and Dryer we've done quite a bit, where people want to either relocate some of their equipment to another one of their own facilities, or they want to buy a piece of equipment and move it over. So when we go in, we look at, what's all in the way, what parts do you really want to take with you, or what parts, you may just want to leave behind, like the bases, do you want to make new bases or take the old ones out? And, figure out how many truckloads, weight wise and, all the shipping restraints to that. And can come up with a pretty good number of what it would take to relocate equipment or to move used equipment around.
And is that something?
Go
ahead, Tom.
Go ahead. You go ahead, Pete. Just say what you need.
Sure. I was just wondering who does that. Is that a third party company as well, a logistics firm or the engineering firm? I'm trying to figure out how you.
That is something that Industrial Kiln and Dryer will do. We have field crews out there all over the U.S. that's one of the common things that we can do for customers.
Demo and put back up.
Yep.
The one point I'll put on the logistics of it, it's a very important question. It's usually a major number in your equation, but we really find that people ask that question way too quickly.
Right. I mean, I think I talked a little bit about the example here is one of the groups wanted to dry material, bought a kiln, and then was asking me, you know, we're going to move this kiln to dry this product. And my initial thought was, I don't think you can use a kiln for a drying because you'll probably end up with burnt material coming out. And they already spent the money logistically to move it, save the refractory inside, and it's just sitting there not usable for that particular case.
We find that quite often.
Yep.
Wow. I do have a question that was just submitted. Is it possible to utilize a mixer dryer that is used to manufacture asphalt to dry frac sand, realizing it may be very inefficient?
Well,
that's Trey.
oh yeah.
Trey.
Yeah, we got some stories on that.
Trey, go ahead.
Is it possible? Yes. Should you do it? Probably not.
You're gonna run into running expenses that are probably that you're not taking into consideration.
One of the things that industrial kiln and dryer sees is, you know, the frac sand dryers are running 24 hours a day nonstop.
Yes.
Most of the asphalt dryers are not running near that amount of uptime. They also are made a lot lighter and they're not made for a long longevity. They wear out relatively quickly compared to an industrial grade piece of drying equipment that's made properly that will run for decades on end.
Right.
So if you go into that, again, it goes back into looking at your numbers and ROI
right.
on what do you expect your maintenance is going to cost going down the road. How long do you expect this piece of equipment to last with your eyes open, knowing it's not going to last like a piece of industrial equipment. It's going to last like an asphalt dryer, which isn't that long.
Yeah, asphalt's seasonal, so you're not running all year. It's what we call a 2,000-hour unit. And if it's an industrial grade designed for 24/7 operations, that's what we call an 8,000-hour dryer unit. So if you buy the wrong, like Mike said, buy a lighter duty and expect a different ROI 24/7, then you'll probably run into trouble. Hence our comments.
All right, great. And then there was a comment, any back of the envelope on the math on costs of breakdown, transfer, installation as a % of the original costs or $1 per mile per ton?
Oh, yeah. I mean, that varies all over the place.
Yeah.
Yeah.
I mean, some of the pieces of equipment are incredibly heavy and incredibly large, so there's a pretty big price difference.
Okay. Well,
We try not to swag.
Let me see if there's any other. Any comments on rotary versus vibrating fluid bed versus static fluid bed?
Each have their purpose.
Yep. Rotary tends to be the higher throughput. Fluid bed, you get better air contact with it. This is where you get into the details of your particular product that you want to make. It depends on the size of the material going in, and it depends consistency. So I would say you get more air margin on a rotary dryer. On a fluid bed, it's a little bit tougher to optimize, and it tends to be overall larger in just square footage for what you're doing. But they both have their pluses and minuses.
Okay. Great. Well, I think that wraps up all the questions we have right now. you'll see on the screen there Tom's contact information. If you have any additional questions, anything you didn't want to share in front of the group or ask in front of the group, shoot a note to Tom. Or if you have anything for any of the panelists, shoot it to Tom and he can forward it over to any of the panelists. But I think that wraps up our webinar for today. Tom and panel, thanks so much for your participation and sharing your insights and expertise. We'll make a recording of this webinar available on the website so people can sign up later and register and get a chance to watch it. But thanks very much, guys. We appreciate your time, and we'll stay in touch.
Thank you.
Thank you.
Thank you.